Welcome back. This is the third lesson recording for IM2, October 8th, 2020. So let's talk about similarity notations. So how do we communicate two polygons are similar? So instead of saying that, we can use the letters and say PQRS with this squiggly symbol and this is read as the similar. This is PQRS is similar to ABCD. And this key, if you're using your laptop, is on the top left corner. It's the left of number 1 key, and it's the one that you would use with the shift. So you can find that in your keyboard. What's important is, just like congruence statement, that corresponding parts are encoded in position. That means that P corresponds to A, that Q corresponds to B, and R corresponds to C, and S corresponds to D. Okay, just like P here corresponds to A according to here. That means we can say that these two vertices are congruent, or the angles are congruent, and Q corresponds to B here. Okay, and R corresponds to C here, and S corresponds to D here. Okay, so you're probably noticing that I'm using slightly different notation for the arc, that are the angle measures that are congruent. This is another form of, instead of using just one arc, I can use one arc with different number of notches to indicate the angles that are congruent. Okay, so then how do we write ratio statements? As I have shown you before, you find the corresponding part. Okay, so then here you go. You have PQ here. PQ corresponds to AB. If you know that to be true, then you write PQ is over AB is whatever the number. Okay, say this is 2 and 3, that will be 2 over 3. Okay, and if I was to talk about these two corresponding sides, I would write QR over BC is, let's just say this is 4 and this is 6, is 4 over 6, and so on. And you would do it for each one of the sides. Okay. Alright, so then it's your turn to try this. Please open up Desmos and try card number 1 to 9. And if you are following it from home, please go on to student.desmos.com and use the class code to join. And please pause the video and do that now, and I am going to go through it really quickly. Okay, card number 1 says, complete the sentence. If two polygons are similar, then their corresponding angles must be what? Congruent, or same in measure. Okay. Or we can say equal, will be fine too. Complete the sentence. If two polygons are similar, then the corresponding sides must be not congruent, but what? Proportional. Okay, that means it's not the same, but you can use a common same scale factor or the ratio between the corresponding sides are equal. Okay, to conclude that two polygons are similar, we have to verify that which one? Do orientation have to be the same? No. Does all corresponding angle has to be equal? Yes, that has to be true. And all corresponding angles are proportional. Yes. Then angles do not have to be proportional. They have to be equal. All corresponding sides has to be proportional, and all corresponding sides are equal. No, that doesn't have to be true. Okay, similarity statement. What would be the correct similarity statement? Make sure the corresponding parts are matching in position. So I know that W matches up with P. I know that X matches up with Q because of the angle arc measure, and Y matches up with R, and Z matches up with S. Okay, and we're told that, well, let's check. Are the sides proportional? What's the multiplier between 4 and 6? It's 1.5. Okay, if I multiply 1.5 by 6 to 9 becomes 9. 8 times 1.5 is 12. 10 times 1.5 is 15. So the sides are proportional. So yes, the two polygons are congruent. So that means I just need to match up. So W matches up with P, X matches up with Q. And remember, when you are naming polygon, you need to go in one direction. You can't sort of just mix around W, Y, X, Z. It has to go in one direction. So W, X, Y, Y corresponds to R, and then Z corresponds to S. So, and we use that wiggly line to indicate that they are similar. Okay, what about this? Mr. Pinza is scratching his head about similar polygons. He eavesdropped and knows that polygons are similar, but the ratios he calculated below do not come out to be the same. So what did he do wrong? Well, xy over pq, xy over pq, xy over pq is 6 over 4. That's correct. xy over qp, xy over qp is 15. Okay, I think this is a typo. Okay, this is supposed to be xw over qp is 15 over 10 is 3 over 2. Okay, that's correct. rs over yz is 6 over 9. That's correct. And ps over wz, ps over wz is 8 over 12, which is 2/3. Okay, what did he do wrong? Well, what he did wrong was that xy belongs to the left-hand triangle, this triangle, or this polygon. This is this side here, okay? And then qr is the right triangle, right polygon. But here, he's starting with rs here. So he should be writing yz over rs, which would be 9 over 6. So he has reversed the numbers. Okay. Okay, write the three ratios you have to calculate and to decide if the corresponding sides are proportional. So let's start with AB over which is the corresponding side. AB is opposite the angle with one arc. So angle with one arc is here. We're talking about ED. Okay, so and AB is 6 and ED is 3, which is same as divide both sides numerator and denominator by 3, you get 2 over 1. Okay, so that was AB over ED. Then let's do BC over, and which is BC is opposite the angle with 2 arc. The angle with 2 arc is here, so we're talking about this. Okay, I know it is pretty obvious from this diagram which is corresponds to which, but sometimes you're going to get triangles that are very similar in length, and then you are not going to be able to tell just by looking at it. Okay, so that's why I am going through it more slowly. So BC over EF is 8 over 4, which is same as 2 over 1. And then finally, the last one is AC over EDF. AC over DF is, AC is 10 over 5, which is 2 over 1. So since the angles are congruent and all the sides are proportional, we can say yes, it is proportional. The two are similar, and you can explain that just there. Alright, then, and similarity statement. Okay, now that we've said that they are similar, how do we communicate that? We need to start with W. Okay, we can say W, Wx, Y, Z, Wx, Y, Z is similar to W corresponds to P, X corresponds to Q, Y corresponds to R, and then finally S. So that would be my statement. Okay, and then Mr. got his ratio right this time too. Thank you. Let's get back to our slides. So using similarity level 1, the triangles are similar. We are told that they're similar. Find X and Y. So we need to figure out what X and Y is. To do so, you need to identify a pair of corresponding sides with known ratio. What do we know that is the corresponding sides? That's 40 and 30. They're the corresponding sides. That means we can say, set up the ratio equation to maintain the same order. Okay, so we know that X corresponds to 18. So that's going to be 40 over 30 is equal to X over 18. And then finally you solve. How do I solve this? I am going to multiply both sides by 18 because X is being divided by 18. And then here I've used the cross multiplying method where I'm multiplying 18 with 40 and 30 with X, and you get 720 is 30X, and then from there you're dividing by 30 again to get X to be 24. What about Y? Okay, 40 over 30, 40 over 30, okay? The side is equal to 36 over Y. And then from here I am cross multiplying and get my final answer is 27. Okay, so then now you're going to try to do the decimals, card number 10 to 13. I'm running out of time, so I'm going to do this really quickly. I know that JKLM is similar to PQRS. J corresponds to P, and K corresponds to Q, and L corresponds to R. So I know that matching them up, 10 over Z is equal to 15 over 6, or alternatively you could say Z over 10 is equal to 6 over 15. Okay, and I would expect x to be bigger than 10. Why? Because